In this example, we're going to solve another problem related to polynomial systems. Again, the problem is going to be a long problem suited for a long 4-hour exam. All right, let's read the problem. ABCD is a rectangle. So this is my rectangle ABCD. So I'm having a rectangle there. Points E, F, G, and D. So points E, F, G, and D form a square as indicated. So this here is a square. What else are we given? We're given that ED, so this distance here, is equal to this distance, DG, which is equal to X. We're also given that AB, this distance here, is 2x. X is an unknown at the moment. And we're given that this distance here is y. That's not all. We're also given that BF, so this distance here, BF, that is 5 centimeters. And the final piece of information that we're given is that the whole perimeter of the big rectangle, so the perimeter of this rectangle is 26 centimeters. What are we being asked? We're being asked to find x and y, so to speak, to find the dimensions of this picture, so as to make this possible. So what are the values of x and y which make this picture possible? We're also asked that y be greater than x. So how are we going to solve this problem? From the text of the problem, we're going to extract equations that relate x and y. And once we have those equations, we're going to form they're going to result in a polynomial system with respect to the variables x and y, and then we're going to solve that polynomial system. So let's read what we have. We have that the perimeter of the rectangle is 26 centimeters. But the perimeter of a rectangle is, of course, that's my rectangle, and of course the perimeter of a rectangle is 2 times the width plus the height. And the width happens to be 2x, because that was given to us, and the height happens to be y, that was given to us too. Here's the height. Okay. Now, both sides of this equality are divisible by 2, so we can divide 26 by 2, and 26 divided by 2 is, of course, 13. So I'm dividing both sides of this equality by 2. Now, what you can see here is that you can very easily express y as a function of x. I can take those 2x, so I can take 2x, transfer it to the right hand side, of course, then the 2x acquires a minus, and I'm left with the fact that y is equal to 13 minus 2x. In this way, I have managed to eliminate the variable y in favor of the variable x. So every time now I see the variable y, I can simply replace it with 13 minus 2x. Okay, so now the next thing I need to do is I need to somehow exploit the rest of the given information. I haven't taken any advantage so far of the fact that BF, so this segment here, is equal to 5 units. So I haven't taken advantage of this fact here at any point. I took advantage of the fact that this side here is 2x. I took advantage of the fact that that side is y, but I haven't exploited the information about BF at all. So let's do that right now. So I need to relate the length of the segment BF to the remaining lengths in this problem. So what I'm going to do is the following. I'm going to take this point F, and from it I'm going to drop a perpendicular towards the segment BC. And the heel of that perpendicular, I'm going to call it H. So that new point, the heel of that perpendicular, I'm going to call it H. So once again, I'm taking the point F and I'm dropping a perpendicular towards the side BC, and the heel of that perpendicular I'm declaring it to be H. Okay. So now, how does that help us find what BF is equal to? Well, let's see. Here I'm having the triangle BFH. So triangle BFH happens to be a right angle triangle. So I can take that triangle BHF, and this corner of the triangle is right. So I'm having a right angle triangle. Okay, so I have a right angle triangle. BHF. And what does the Pythagorean theorem say about a right angle triangle? Well, if this side is A, if this side is B, and the hypotenuse is C, the Pythagorean theorem states that the hypotenuse squared, C squared, is equal to A squared plus B squared. So the hypotenuse squared is equal to the sum of the squares of the two legs of the right angle triangle. So let's see what that tells me about this particular right angle triangle. It tells me that BF, the hypotenuse, so BF squared is equal to this leg squared, the leg A squared, so that's this leg, FH, plus that leg, BF squared, plus that leg here, which is not labeled at the moment, that leg squared. Okay, so now using the Pythagorean theorem, I was able to establish that BF squared is equal to BH squared plus FH squared. So this guy squared is this guy squared plus that guy squared. All right. Now, I actually do know the quantity FH. So the length of the segment FH, that's certainly equal to the length of the segment GC, this one, which is certainly equal to this length. It's certainly equal to the length DC minus the length DG. And the length DC, that's the same as the length of AB, because this is a rectangle, ABCD is a rectangle. So DC is equal to 2x, right? So DC is equal to AB, which is 2x. And the length of the segment DG, so that guy, it was given to us to be equal to x, if you remember. So 2x minus x, so 2x minus x is x. So the segment FH is equal to x. Similarly, the segment BH equals, well, it's certainly equal to the segment AE, this guy, and that's certainly equal to AD, this larger segment, minus the smaller segment here, minus x, the smaller segment here, the segment ED, that was x, so ED was equal to x, that's the segment ED. But the large segment AD, that's the same as BC, so that is y. So the segment BH, so this segment here, is y minus x. So segment BH is y minus x. All right. And finally, I was given in the problem that the segment BF, this diagonal here, equals 5. So BF squared is 5 squared. All right. Now, let me uncover the parentheses a little bit. Y minus x, the whole thing squared, well, that certainly is equal to y squared minus 2xy plus x squared. That is simply the quadratic formula. What I have also done is I've taken 5 squared and I've transferred it to the left-hand side. Because in this way, I'll be having, so when I end up replacing y with x, I'm going to be having a quadratic equation. Okay. Next, let's combine the two x squares. So x squared plus x squared is 2x squared. And let's remember that 5 squared is 25. Everything else has been copied. Okay. Now, let's see what has happened so far. Using the conditions for the perimeter of my rectangle, I was able, in the start of the problem, to establish that y is equal to 13 minus 2x. And using now the conditions on this segment BF, I was able to establish the second relationship between y and x. So what I have is a polynomial system of two variables, the variables y and x, and two polynomial relations. This is the first equation, this is the second equation. Now, luckily for me, the first equation already tells me how to solve the system, because it tells me that I should take the variable y and replace it with 13 minus 2x. So that's exactly what I'm going to do. I'm going to take the variable y and simply replace it with 13 minus 2x. Okay, now my system has been transformed to a system of one equation with one single variable, namely the variable x. All right, so let's uncover the parentheses. So now I'm going to uncover all the parentheses here. As you can see, this expression is rather large, so I'm going to uncover all the parentheses. Okay, so the parentheses uncovering is already worked out for us, but let's do the work. Let's show that the work in the slide is correct. So let's uncover the parentheses for 13 minus 2x, the whole thing squared. So 13 minus 2x, the whole thing squared. So the slide claims that that's 169 minus 52x plus 4x squared, but let's see if that indeed is the case. 13 minus 2x squared is certainly equal to 13 squared minus 2 times 13 times 2x plus 2x squared, which equals, what's 13 squared equal to? 169. Of course, we expect it to be 169, but so I personally have 13 squared memorized. Once again, it's a very good idea to memorize the small squares for the purpose of solving problems fast. But if we have forgotten that, we can simply multiply 13 squared very quickly on the side. 13 squared is 13 times 13. 3 times 13 is 39, and 1 times 13 is 13. And when we add the 2, we're getting 169. Now here I'm having 2 times 13 times 2, so that's 4 times 13. Now 4 times 13 is the number of cards in a standard deck of cards, so that's 52. And 2x squared, that's 4x squared. So indeed, 13 minus 2x, the whole thing squared, is equal to 169 minus 52x plus 4x squared. Next, negative 2x times 13 is negative 26x, and negative 2x times negative 2x is plus 4x squared. Okay, now let's combine like terms. 2x squared plus 4x squared plus 4x squared. So 2x squared plus 4x squared plus 4x squared. That's 2 plus 4 plus 4 times x squared, which is 2 plus 8 times x squared, which is 10x squared. Okay, so we're having 10x squared from these. Next, minus 52x minus 26x, well, that is minus 78x. And finally, 169 minus 25, that is 144. Okay. Next, let's notice that the three coefficients that I have here, they're all divisible by 2. So let me divide both sides of this equality by 2. When I divide 10 by 2, I'm getting 5. When I divide 78 by 2, I'm getting, well, 39. And when I divide 144 by 2, I'm getting 72. There we go. So we have now, we are now left with a single quadratic equation, which we know very well how to solve. Now, as you can see, these computations were rather long, so I ran a little bit out of space. So what I'm going to do next is I'm going to hide a few of these formulas. Now, if you're working out this problem on a piece of paper with me, you can now, you can just you can pick another piece of paper. But what I'm going to do is I'm going to hide most of the formulas that you see here. So let me do that right now. So what's going to be left is the two highlighted formulas are going to be left, and most of the other formulas are going to be hidden. There we go. And I'm going to move my formulas to the side. So y equals 13 minus 2x, and 5x squared minus 39x plus 72 is equal to 0. Now, you could try to factor this quadratic. So you could try to factor. So you could try to guess a factorization. Now, based on my experience solving problems, I find that a quadratic with such large numbers, 5, 39, and 72, is difficult to factor, or it's difficult to guess the factorization of such a quadratic. So I do challenge you to right now pause the video and try to factor this quadratic. However, I personally am I will not take up that challenge. That may be too difficult a challenge for me. So I will just use the quadratic formula. But if you are brave, you can try to solve that quadratic without the quadratic formula right now. Okay, now let's solve this quadratic with the quadratic formula. What are the two solutions to this quadratic equation? Well, the two solutions, I'm sure you have guessed it, the two solutions are given by the formula minus b plus or minus radical of b squared minus 4ac over 2a. Of course, I didn't want you to give me the final answer. I wanted you to give me the formula for solving the quadratic. Now, simplifying that formula is going to take a while. All right. So the number b, that's equal to negative 39. Of course, when you square negative 39, it's the same as plus 39. The number a is equal to 5. And the number c is equal to 72. Okay. So now the numbers here are relatively large. It will take a while to simplify, but I will be simplifying these numbers under the assumption that we do not have access to a calculator. Once again, this is supposed to be an exam-like problem, and on such an exam you may be in a position to not have access to a calculator. So minus with minus, that gives me plus, so I'm getting plus 39. Now, I claim that 39 squared is equal to 1521. Let's quickly compute that. 39 squared, I can compute that as 39 times 39. So 9 times 9 is 81, 1 and 8 carry over. 9 times 3 is 27, plus 8, that's 35. 3 times 9 is 27, 7 and 2 carry over. 3 times 3 is 9, plus 2 is 11. 5 plus 7 is 2 and 1 carry over. 3 plus 1 plus 1 is 5 and 1 is copied down. So indeed, 39 squared is 1521. Alternatively, I could have computed 39 squared like this. 39 squared is certainly equal to 40 minus 1, the whole thing squared, which is equal to 40 squared minus 2 times 40 times 1 plus 1 squared, which is equal to 1600 plus, minus. So 1600 minus 80 plus 1. Now 1600 minus 80 is 1520 plus 1, which is 1521. Okay, so the slide is correct. Okay, and let's compute the other one. 4 times 5 times 72. 4 times 5 times 72. That's certainly equal to, well, the product of these two guys is 20. So 20 times 72, which is equal to 2 times 72 is 144 times 10. So that's 1440. So that is correct as well. Okay. 2 times 5 is of course equal to 10. Now 1521 minus 1440, that's certainly equal to 81, right? So 1521 minus 1440 is, well, 1 minus 0 is 1, 12 minus 4 is 8, I've subtracted 1, and that's it, 81. So that is certainly equal to 81. Okay, and now a radical of 81, what's that equal to? Well, I'm sure you know that that's equal to 9. So I'm getting 39 plus or minus 9 divided by 10. Now I run out of space again, so if you don't mind, I'm going to hide the formulas that you see in here. So I'm going to hide these formulas, and I'm going to move this formula up. Right, so let me do that. Once again, if you're working this out in parallel with me on a piece of paper, you can just, if you run out of paper, you just take another piece of paper. Okay, so let me move that up. There we go. Here are my two solutions, 39 plus 9 over 10 and 39 minus 9 over 10. So it seems that we're having two cases. The first case is that the original x is equal to 39 plus 9 over 10. So that's our first option, 39 plus 9 over 10. That is, of course, 48 over 10. Now 48 over 10, I could simplify that as 24/5 if I so desired. But in this particular case, I'm going to deviate from my usual custom, and I'm going to use decimal point. So that's just 4.8. Let's use decimals here. Won't hurt us. Okay. Now, of course, you could compute with rational numbers as well. You don't need to go to the decimal notation, but this time let's use decimals. Okay. Now, what about y? I found x, right? So what about y? Well, y is equal to 13 minus 2x. So y is 13 minus 2x. But we already said that x is equal to 4.8. So I can replace x with 4.8. Now, 2 times 4.8 is certainly 9.6. And 13 minus 9.6, well, that's 13 minus 10 minus 0.4, which is equal to 13 minus 10 plus 0.4, which is 3 plus 0.4, which is, of course, 3.4. Okay. So y is equal to 3.4. So we have our solution. X is equal to 4.8 and y is equal to 3.4. Or do we? Let's be super careful here. Let's read the problem again. What does the problem say? Find an x and y. Sure, we found x and we found y. But the problem says something more. The problem requests that y be greater than x. Is that the case? Is 3.4 greater than 4.8? No, it's not. So since 3.4 is less than 4.8, that means that x is bigger than y. So I have to reject this solution. So I am rejecting this solution because of an extra condition, which I almost overlooked it. So I almost overlooked that extra condition. Mind you that if that happens to you on an exam, you will surely lose points. Right? So that's a very tricky problem. Well, it is what it is. Okay, we took care of case 1. Now let's take care of case 2. Case 2 is that x is equal to 39 minus 9 over 10. So 39 minus 9 over 10. That's my next case. So x is 39 minus 9 divided by 10. And now 39 minus 9, that's 30 divided by 10, that's 3. So I'm getting 3. And now what's y equal to? Well, y is equal to 13 minus 2 times x, right? We remember that from the start. And now x is equal to 3, so I'm getting 13 minus 2 times 3, which is 13 minus 6, which is 7. So now 7 is bigger than 3, that is x. So that solution satisfies the requirement that y be greater than x. And so we have obtained the solution to our problem. So our final answer is x equal to 3 and y equal to 7. Our problem is solved.